The major cytoskeletal protein of most cells is actin. Individual actin molecules, also called G-actin, are globular proteins of 375 amino acids. G-actin is described as having a pointed end and a barbed end. G-actin monomers polymerize to form actin filaments. The assembly begins with the nucleation of 3 monomers to form a trimer. Polymerization is reversible and proceeds from both ends, yielding a filament called F-actin. Polymerization is a reversible process in which monomers both associate with and dissociate from both ends of the filament. At high concentrations of free subunits, the filament grows at each end, but growth is faster at the barbed end. When the concentration of free actin monomers falls below a certain level, the barbed end will continue to increase in length, but the pointed end will decrease in length, resulting in a phenomenon called treadmilling. Treadmilling can be depicted in a cycle diagram in which there is a net gain of subunits on the barbed end and an equivalent net loss of subunits on the pointed end. The treadmilling cycle depends on ATP, which is bound to monomers that add to the ends of the filament. Actin monomers at the barbed end are therefore bound to ATP. However, soon after polymerization, ATP is hydrolyzed to ADP, resulting in a zone of ADP-bound monomers toward the pointed end of the filament. ADP-bound actin, which is primarily at the pointed end of the filament, dissociates more readily from the filament than ATP-bound actin. In contrast, actin bound to ATP associates more readily with the rapidly growing barbed ends. ATP binding and hydrolysis play a key role in the dynamic behavior of actin filaments. In the cell, 2 types of proteins, including one called formin, determine where filaments are formed. Formin binds to monomers and facilitates the nucleation process in which 3 monomers are joined to form a trimer. After nucleation, polymerization proceeds quickly. It is thought that formins nucleate long unbranched actin filaments, such as those in a muscle cell's thin filaments. At the leading edge of moving cells, actin filaments treadmill and branch extensively. The branches are nucleated by the ARP23 complex, which binds near the barbed ends of microfilaments and forms a new branch. ARP23 helps promote the remodeling of the actin cytoskeleton that's required for cell movements and changes in cell shape.